laser focus on this concept, we can get like this. Okay, this conclusion we have find, and now we will discuss some important questions, some important problems before we discuss some important properties of the logarithm. Important properties of the logarithm. So now let us discuss these important properties, and best examples we will also give. So this log m into n, if both the numbers are positive in argument form and a is positive, m and n is obviously positive. So this can be written as, if they are in multiply form, we can separate these two, log m base a plus log n base a. We can write this as log 3 base 6. This can be written as 3 base 6 can be written as 2 into 3, and example is log 3 base 2 plus log 3 base 3. These are examples. Similarly, if we are given log 3 upon 2, if any base 5 base, we can write it as log 5 base 3 minus log 2 base 5 minus. It is the difference rule. And if any power is given, log x square 2, we can write it as 2 log x base 2. Similarly, if 2 square, we can write 1 upon 2 log x base 2. If the power is in base form, then we will then if we come out this power, then it will be reciprocate. Now we have the base important theorem, that is base change theorem. That is log 2 base 3. If there log 2 base 3 is written, then we can write it as log 2 upon log 3, and we change the base accordingly positive. Log, if we take 5, then here we will take 5. Okay. Similarly, log b base a into log a base b equal to 1. How this happens? See, log b base a can be written as log b upon log a, and this can be written as log a upon log b, and this will cancel out, we will get 1. Similarly, this we can write like this, and we can cancel out, we get this. And similarly, if we have powers in both in base and argument, it can be written as power base coming from in the upper side, and the base power is coming in reciprocal form, so n upon k, that is log 5 square 3 k cube. We can write it as 2 upon 3 log 5 base 3. Okay. And 9th number is important property, that is 5 ki power log 5 base 3, it is only 3. Okay. And 10th number, 5 ki power log 7 base 3 is equal to, this can be written as 7 can be transformed from in place of 5, and 5 can be transferred to in place of 7. Okay. These are the important properties of logarithm. Okay. Now we will discuss the properties, the problems based on the important properties. Problems based on the important properties. Okay. Question is log tan 70 degree tan to the base tan 20 degree. What will be its value? Its value is, see, its value is, here the argument is tan 70 degree. Tan 70 degree can be written as tan 90 degree minus 20 degree, and tan 90 minus theta is what? Cot theta. Cot 20 degree, and cot 20 degree can be written as 1 upon tan 20 degree. This must be you have learnt in class 9th also in trigonometry. Okay. So tan 70 degree, tan 90 minus theta, its formula is working here. So we can write log 10 20 degree into 1 upon 10 20 degree. Now these base and arguments are reciprocal. What will be its value? -1. Got it? -1. It is an important concepts to be grasped before solving the problems, before solving the bigger problems. Okay. Now take a second questions. Log 2 minus root 3. And in the argument we have 2 plus root 3. Okay. 2 plus root 3. Let us write in phrase this 2 plus root 3, 2 minus root 3. This we have to find. Now, these are the important rational numbers such that, see, 2 plus root 3 into 2 minus root 3 in 9th class or 10th standard you must have read that it is a plus b into a minus b is equal to a square minus b square. 2 square minus root 3 square. 4 minus 3 is equal to 1. So this product is 1. So 2 plus root 3 can be written as 1 upon 2 minus root 3. So again we can write log 2 minus root 3, and in place of this we can write 2 plus root 2 1 upon 2 minus root 3. Therefore the base and arguments are reciprocal, so its value will be -1. Got it? Question number 3. It is a laser focus problems. 0.9 bar. 0.9 bar. Now, one thing must be bear in mind from the earlier class that 0.9 bar is equal to 1. How? Somebody thinking that? How? Let x is equal to 0.9, 0.99. 0.9 bar can be written as 0.999, recurring like that. So 10x will be 9.99. Now subtracting first from second, we get 9x is equal to 9. Therefore, x is equal to 1. Could you follow? So, this can be written as log 10 base, log 1 base 10. So, what will be the answer? It is 0. You have already did. So the basic concept must be grasped proper to before solving the problem. I have shown you that how these concepts are applied, how these laser concepts are applied frequently in day-to-day logarithmic problems. Okay. Now the fourth question we also want to discuss here. Fourth question. Log. What is the value of log 5 this to infinite? Now let us solve first this. You must have solved in the earlier classes, like it is an interesting one. So the 5 is repeated infinite times, so let this be y. Let this as y. Y is equal to under root 5y. This implies y square equal to 5y. We transfer y square minus 5y equal to 0. Y into y minus 5 equal to 0. Y equal to 0 and 5. But 0 is not possible. Since a square root is a positive number, a square root quantity is a positive quantity. Its output is positive. Output always positive. Positive, but 0 is not valid because a square root of some positive number, a square root 0 can be available in a square root, but here the positive quantity, a square root is always positive, something greater than 0 but not equal to 0, because a square root of 5 like this So this cannot be 0. Therefore y is equal to 5. And if we take y as 5, so log 5 base 5 is equal to 1. Number, same base, same argument, that is 1. Okay? Got it? Now we shall discuss some of the basic and important problems before we move further to solve JEE questions. Okay? So before solving JEE questions, let us solve two more problems based on the above learned properties. Okay? Find the value of log 1728 2 root 3. And second, 7 की power log 5 base 3 plus 3 की power log 7 base 5 minus 7 log 3 base 5 minus 5 log 7 base 3. Now let us solve this. Let it be x. So therefore, by the theory of the logarithm, if a की power x is equal to n, this implies x is equal to log n base a, where a is greater than 0, a is not equal to 1, and n is positive, obviously. Okay? Base cannot be 1. So now 1728 can be written as 2 root 3 की power x. And interestingly, if we square root of this, square root of 12, 2 will move under the square root, it is 12, and 1728, that is 12 cube. So this can be written as 12 की power x upon 2 equal to 12 की power 3. This implies x upon 2 equal to 3, therefore x equal to 6. Could you follow? Now, one important property we have learned, some ninth number property. We can you can see that ninth and 10th number property.